Cool. So, can you explain me whatever we studied in the last class? Do you still remember that?
Ma'am, we have studied what is mean by distance and displacement.
Okay.
Average.
What, Ms. Ba?
Average speed
Average.
and instantaneous speed.
Okay.
Average velocity and instantaneous velocity.
Okay. So, I guess we have discussed about distance, displacement, speed, velocity, and they are further division into two categories: average and instantaneous. I told you, I think I believe I told you this thing in the last class, that whenever you have a duration of time, always go with the average. Okay. Whenever you have a statement like this, from t is equals to 0 second to t is equals to 2 second or something like that. So basically you have a duration. But if your question is interesting only at 4th second or 5th second, in that situation you should go with the instantaneous word, right? And it goes on with the speed as well and with velocity as well. So if you know the basic meaning of speed and velocity, you are already know how to classify into average and instantaneous one, right?
Yes, ma'am.
Right. I guess I told you this statement also, the distance is always greater than or equals to the displacement. If we have a one dimension motion in which there is no returning of the object, then in that situation we have displacement equals to displacement. Okay,
Yes, ma'am.
cool. Besides it, I think we have discussed about the slope of displacement time graph. For example, I
Yes,
have
ma'am.
something like this. This is S, this is T, and I draw something like this. So can you give me the idea about its slope or what it, yes, I think somebody raised their hand. Okay, Rishabh and Ramesh. Answer करोगे आप? What is the slope of displacement time graph? Hmm? Anyone? ज़्यादा पुरानी बात हो गई क्या? Hmm?
No,
Ma'am,
ma'am.
it means velocity.
Thank you, Arsh. That's velocity. Very good. Very nice. And I also tell you this thing, ki always measure the theta from the positive x-axis, right? So slope can be written as m is equals to 10 theta. And when it comes to displacement time, displacement versus time, then the slope of this graph is equals to velocity. Okay? Is it fine?
Yes, ma'am.
Ma'am.
Cool. Always remember, I believe ki, around 70% of the questions that you are going to deal under this topic, they belongs to a straight line. So for that matter, you should know about the equation of a straight line. This is equation of a straight line.
Y is equals to mx plus c.
Very nice, very nice. Y is equals to mx plus c, where y and x are the coordinates. Okay, m is the slope and c is the y-intercept. I explained you in the last class, intercept it is. So I explained you this thing in the last class, that y-intercept can be of three types, right? It could be positive, it could be 0, and it could be negative. Okay. For example,
Yes,
in
ma'am.
this question, you have a positive y-intercept, right? Y-intercept basically that value of y for which x is 0. Okay. So if somehow I cut the graph like this, then it's gonna meet somewhere here. It would have negative y-intercept. And if I start some equation from here, then it would be a straight line with 0 intercept. Is that okay?
Yes, ma'am.
Okay. So these are the things that we have already discussed in the last class. Okay, here I have a question that you have to find. Okay, I'm giving you a question. We have x is equals to t square. The first part to this question is find the instantaneous velocity at t is equals to 4 seconds. Okay, and the second one, find the velocity from t is equals to 1 second to t is equals to 4 seconds. Okay, you have two parts to this question. So just solve it. I will give you the time. It's 17:56 right now. Give me the answers within 2 minutes. And just raise your hand. I will ask. Okay. Okay, Tamanna. Is question clear to you all? Question समझ आया?
Yes, ma'am.
No, ma'am.
Harshda, I gave you a relation in between displacement and time. And now I want you to solve the first part is instantaneous velocity at some instant. And then you have a time interval. So you need to find out the velocity in that time. You have a relation in between displacement and time. Is it clear now?
Yes, ma'am.
Okay, so time is up. I got only one hand, and that is of Tamanna. Tamanna, can you explain me answer to this question, beta?
यस मैम, इसमें हम विकलन करेंगे, इसलिए पहले वाले में आंसर आएगा 8 एंड सेकंड वन आंसर आएगा 3.75.
Okay. Can you tell me more about the procedure that you follow?
फर्स्ट हमको जो उसका टी रेस टू है ना, उसको आगे के वाले से मल्टीप्लाई करना है, इसलिए 2t आया. टी के उस तरह हम 4 रखेंगे तो 4 से मल्टीप्लाइड बाय 2, तो फर्स्ट का आंसर 8. एंड सेकेंड में हमें करना है कि जो s इज इक्वल टू टी है, उसमें हमें दोनों टाइम रखने हैं, t1 एंड t2. उसमें
Okay.
1 रखेंगे तो 1 ही आएगा, और 4 रखेंगे तो 16 आएगा. 16 में से एक निकालो, 15. 15 को बाई 4 करो, इसलिए 3.70.
Okay, that's cool. Okay, let me solve first. So we have a relation in between displacement and time, as you can see over here. S is equals to t square. As you can see that in the first question, we are interested only at the 4th second, right? And also I mentioned here instantaneous word. So it's pretty clear to you that you have to find out the instantaneous velocity. And instantaneous velocity is nothing but the differentiation of displacement with respect to the time. So you have an equation, just substitute the value. I know that it is going to be like this, right? I hope you remember the formula that dy dx of x raised to the power n is equals to nx raised to the power n minus 1, provided n is not equals to 1. Is that okay?
Yes, ma'am.
Oh, ma'am.
Okay. Now, I want you to calculate the velocity at t is equals to 4 seconds. So what are you going to do? You have to just substitute at the place of t, the value 4, right? 2 into 4. Oh, wait a second. Yeah. 2 into 4, and it would be 8 meters per second. That's cool. Let's come to the second part of this question. Here I have a range, right? From t is equals to 1 to 4 seconds. Here I have a time interval, a duration. And I told you that for duration, you need to find out the average velocity. So average velocity is nothing but the total displacement upon total time taken. Here I need to calculate from 1 second to 4 seconds. So what you do, you put the S4 minus S1 divided by 4 minus 1, right? So for S4, just substitute a t is equals to 4 in the above equation, right? In this given equation. So it would become 16. For S1, you need to put t is equals to 1 in the above relation, and it would become 1 divided by 3. It would become 15 by 3. And finally, you get the answer 5 meters per second. Is that fine?
Yes, ma'am.
Okay?
Yes, ma'am.
Cool. See, I always believe that you are very comfortable in this class, and if you find something quite challenging or difficult, you are going to ask me, right? This is a precondition in my mind. Please do not shy over here, because literally nobody is going to judge you. Okay? So if you have some doubt, please raise your hand and ask it. See, this is one disadvantage of this kind of scenario, that I cannot see your face. If you are in a physical class with me, I can see your face, I can read your face. Okay? So please do this favor for me. Just raise your hand. Okay, Misbah said she couldn't understand. Misbah, can you be more precise about the point where you are getting difficulty? Like, okay. Where you feel the difficulty? Is it instantaneous velocity or average velocity or what? You can drop it in the chat box even. That's cool. Okay, you can't mute myself. Okay, you can't mute yourself. Okay. So Misbah, can you type it is in first or second in what? Like you are not getting instantaneous velocity or average velocity, or it is the entire question? First part. Okay. See, instantaneous velocity is that velocity where the instant, we are discussing about the instant. dt tends to 0. The duration is tending to 0. I am not concerned about the third second or 0 to 3 seconds or something else. I just want you to calculate the velocity only for 4th second. In that situation, we will deal with the instantaneous velocity, right? Instant. Are you getting the point of instant? Yes, right. So for instantaneous velocity, you are supposed to differentiate the displacement with time. Differentiation is the key to calculate instantaneous things. Okay? Cool. Okay, Mishpa. So, yeah, next time I should not give you the 2-minute lecture and then you will ask me. Just do it naturally, okay? I think I make you that comfortable. Yeah, so please do that. Let's come to the another question. Here you also have a relation between displacement and time. You have to find the velocity at these two particular instants. Okay, so it's 18:05 right now, and solve it till which point? 8:07. Okay, then I will ask you. Now, question is clear now to everyone. Hmm?
Yes, ma'am.
Okay, so time is up, and I got two students to answer. Harshita, do you find it difficult to solve?
Yes, ma'am.
Where are you getting stuck, beta?
I'm not understanding the question.
Hmm?
Not understood the question.
Uh, do you know about differentiation? Is it clear to you?
No, ma'am.
Hmm. So, do you guys explore that bit.ly link which I gave you in last so many classes?
No, ma'am.
Hmm. So please do that. There you have a column, Basic Mathematics in Class 11th. Okay. There you will find 6 lectures. Okay, and I give the title to each lecture, that in that lecture I have discussed, right? Like I have differentiation, integration, vector k 3 lectures, and that is a distribution over there which you can see. So please, it is your pre-work, kindly do it. Okay, otherwise, because it is very simple. Okay, I'm not demotivating you, I'm just telling you that it is very simple. It's that you are lacking at the differentiation wala point, right? So maybe it is fine, it is difficult to you, otherwise you have to just differentiate over here. If you know
Okay,
how to
ma'am.
differentiate it, then it's a very easy question. Gayatri, do you find it difficult also, beta? That's
Yes,
very nice,
ma'am.
Janvi, answer is correct. Gayatri, please. Gayatri, is it difficult?
Yes, ma'am.
So again, you have studied about differentiation, integration, vectors, that basic mathematics.
Yes, ma'am.
Still you find it difficult?
Ma'am, by formula, I found it this difficult, ma'am.
No, no, no. Okay. If you have studied about the differentiation, then it is not difficult. If you know that d by dx of x raised to the power n is nx raised to the power n minus 1. So here you have s is equals to t cube minus 6t square, let's say. So just put it over here. ds by dt. Okay. d by dt of this entire expression. Now, you can write it like this. Is it okay, Gayatri? Harshda?
Yes, ma'am.
Hmm. Now compare this expression by this thing. At the place of x, you have t over here. At the place of
3t
n, you
square.
have 3 over here. So it would be 3x, 3 minus 1?
3x
Yes or
square.
no? Yes. In this part of expression, you have t at the place of x and 2 at the place of n. So you will write 2t 2 minus 1. Okay, if you know the differentiation, then you know we are just going to use the simple one, this simplest formula of differentiation. Now you just have to substitute the values. 3x square minus 12t. Sorry, not x, it's t. This is the velocity, right? Once you get the velocity, you are supposed to put the values. So let's say I substitute t is equals to 1 second over here, then velocity would become 3, 1 square minus 12 into 1. And you will have 3 minus 12, which is minus 9 meter per second. And Janvi, give me the correct answer. Okay. The other one is t is equals to 3 second. And it would become v is equals to 3 square minus 12 into 3. It is 3 ka cube, which is 27. 27 minus 12, 3 is 36. And again, it is minus 9 meter per second. Is it okay now?
Yes, ma'am.
Ma'am, yes, ma'am.
Yeah, Rehana. Please explain me better where are you stuck in? Which is difficult portion for you? Okay. Do you know about the differentiation, integration, and the basic mathematics basically? Have you studied those topics? Okay, then it is quite strange that after studying those topics, you are finding it difficult because I use the very basic formula of differentiation. This is the most basic one. And you just have to put the values. You have to solve the differentiation over there. You have the entire expression that s is equals to t cube minus 6t square. Now I distribute d by dt over this minus so that you can have two separate, terms. Right, Rihanna? Rihanna, are you comfortable with English or should I speak in Hindi? Because I can do that too.
So you can speak in English, ma'am.
Rihanna. Is she fine with English or should I speak in Hindi? Just
Ma'am,
for
I
Rihanna.
don't know Hindi, ma'am.
No, just for, okay, with English. Okay. So, once you distribute d by dt over the negative sign, over that subtraction sign, then you have two different expressions. Okay? Just solve it. At the place of x, you have t, n is equals to 3 over there. Just put nx raised to the power n minus 1, right? So, you can write 3t raised to the power 3 minus 1, that is 3t square. Then put that minus sign and solve the entire expression. As you know that we need to take out the constant out of the differentiation or integration because they are the constants, right? We don't need to focus over there. Just multiply them. Okay, cool. Take care. Tamanna, beta, what is your answer?
-9, -9.
Oh, that's cool. That's cool. Very good. Okay. Just give me a minute. Okay, let's solve this one. In this question, they are asking you to find the time when the body is at rest. The expression for displacement is given as this. Okay, you have a relation of displacement and time. You need to find out the velocity to time where the body is at rest. Is question clear to you?
Yes, ma'am. Ma'am, is it 2 seconds?
Okay. I don't know. We will solve it. Let me just give you the time. Okay, answer only after that. Okay, see, whenever there is going to be a numerical now, we will follow a rule, a game kind of situation is going to be there. That the rule of this game is key. Whenever a question displays to you, just if you know the answer, just hold it. Okay, for the time duration that I give you, and once that duration is over, you just raise your hand if there is no poll, and if there is poll, then you will answer over there only. There should be no, you should not answer over the mic, over the chat. Okay, because the prime objective of giving a question is that everyone at least try to solve that question. But if you give me answer before the time, or like in the chat or by opening the mic, then students will not solve the question. Either they will copy that answer, or they will just like it, theek hai, ab to ho gaya. So to avoid all of that chaos, we will follow this simple procedure that please wait for that duration. Okay, cool. Okay. Okay. So Harshita, what is your answer?
Ma'am, 2 seconds.
2 seconds. Okay. Janvi said 4. Shikha said 4. Misbah, Mantisha.
4 seconds.
Okay. Mantisha, what is your answer, bacha?
Ma'am, 0.
Okay. Cool. Shikha said 4, right?
Yes, ma'am.
So basically, you guys made a ABCD option for me. One is 0 second, second is 4 second, and third one is 2 seconds. And let me make the option D for you. Okay. So whatever the option I made, that is going to be correct, right? It's 0 second and 4 second both. Let's solve this equation. So they said, find a time when the body is at rest. If I'm saying that a body is at rest, then basically V is going to be 0, right? Right?
Yes,
Velocity is
Yes,
going to
ma'am.
be. So what will you do? You just solve this equation, just differentiate it with respect to time. Differentiate with respect to time. It would be ds by dt, which we known as V, is equals to 3t square minus 12t. In the previous question, I explained the differentiation of the same expression. So as per the given condition of this question, this entire term is equals to 0, and this is equals to 3t square minus 12t. I think it became a quadratic equation, right? Just solve it. So I took 3t common, it would become t minus 4, and this is equals to 0. So I'm comparing the two equations that like 3t is going to be 0, then t is equals to 0, and if t minus 4 is 0, then it is 4. So velocity is 0 at t is equals to 0 second and as well as at 4 seconds. So it's option D. Is that okay?
Yes, ma'am.
Oh,
Yes, ma'am.
cool. Let's come to the question 3. Again, you have a relation in between displacement and time. You have to find the velocity at t is equals to 2 seconds and average velocity between these between this interval. Okay, so you have two parts to solve the here. It's 18:19 right now. Please give me answer after 18:21 only. Okay, do not drop the answer in chat box or while opening the mic. Is it clear to you? Is it clear, bacha?
Yes, ma'am.
Yes, ma'am. Ma'am.
ओके रिहाना, क्वेश्चन ये है कि आपके पास डिस्प्लेसमेंट और टाइम का एक रिलेशन दे रखा है कि डिस्प्लेसमेंट टाइम के साथ किस तरीके से वेरी कर रहा है. आपको वेलोसिटी निकालनी है 2 सेकंड पर और एवरेज वेलोसिटी निकालनी है बिटवीन 1 सेकंड. अच्छा, क्वेश्चन 2, Okay. क्वेश्चन 2 कह रहा था कि आपको अगेन एक रिलेशन दे रहा था डिस्प्लेसमेंट और टाइम के बीच में, और आपसे कहा था कि वो बताइए वेलोसिटी जब मतलब बॉडी रेस्ट में है वो किस टाइम पर रेस्ट में है, मतलब बॉडी। तो हम क्या करेंगे, डिस्प्लेसमेंट से पहले वेलोसिटी का एक्सप्रेशन निकालेंगे, ठीक है। फिर हम क्या करेंगे, वेलोसिटी को 0 रख के टाइम का वैल्यू निकालेंगे। तो दो वैल्यू आई, 0 सेकंड और 4 सेकंड। ये बेसिकली एक इक्वेशन को सॉल्व करने का तरीका होता है कि आपके पास ये जो एक्सप्रेशन है, आप बारी बारी से एक एक को 0 के इक्वल रख दो। अगर मैंने 3t को 0 के इक्वल रखा तो t 0 आ गया, t माइनस 4 को 0 के इक्वल रखा तो t 4 आ गया। ओके रेहाना? जान में आंसर आ गया बेटा?
Yes, ma'am.
T to get those velocity is 60 meter per second.
ओके, नम्रता, हर्षदा, आप भी बताइए।
Ma'am, it's 16 meter per second.
ओके, हाँ न, क्या
16 meter
नम्रता?
per second. 16 meter per second.
कूल। तमन्ना?
-19.
ओके, ठीक है। सो आई गॉट अ स्पेक्ट्रम ऑफ आंसर्स, राइट?
Second
गायत्री,
chance.
डू यू फाइंड इट डिफिकल्ट और यू सॉल्व दिस?
मैम इजी था।
इजी था, ओके।
फर्स्ट में 16 एंड सेकंड में 19 माइनस।
ओके,
Second, ma'am, per plus 19 meter per second. It's positive.
ओके। गायत्री, शिखा, मिसबा, मंतशा, where are your answers, बच्चा? अच्छा, okay. Now, you guys please put your hands down. Now, please, those students raise their hands who find this question difficult, or they are not able to solve this question. I just want their count. Can you do that for me, please? Otherwise, give me the answers. You can't be in both the cases, na? Come on.
Ma'am,
Hmm?
ma'am, I got the average. I got the velocity, ma'am, but I was
Gayatri, your
confused
voice
in
is
average
breaking.
velocity.
Ma'am, 16 seconds.
Okay, Miss Ba got the answer. Gayatri, your voice is breaking. Please come again.
Ma'am, I cleared in velocity, ma'am, but I confused in average velocity.
Okay. See, the average velocity is total displacement upon total time. Here you have the duration 1 second to 4 seconds. So you need to calculate the displacement in that duration only. See, if here I have the duration 0 second, then it is very simple. I will calculate till 4 seconds. But here I have to calculate only from 1 second to 4 seconds. So I have to delete that 0 to 1 second wala part na. I have to delete to eliminate that particular displacement. Yes or no?
Yes, ma'am.
No, Gayatri. Okay, so I understand you get it. Yes, Gayatri?
I can't understand.
Okay. For an example, this is you, okay? This is Gayatri. Let's say you start walking from this point. At this time, t is equals to 0. At t is equals to 1, you are here. At t is equals to 2, you are here. Right? And so on and so forth, like this. You're going like this, so on and so on. Aisa. Cool?
Yes, ma'am.
Okay. Now I said, I want your average velocity from first second to fourth second. Okay. So when I put the values over here, if I put 1 over here, then it will give me this one now.
Yes, ma'am.
But I need to eliminate this portion because I don't need the velocity from this particular displacement, this particular duration. So what would I do? If S1 is going to give me this much distance or this much displacement, and S4 will give me this much displacement, and I only need this particular one. So how would I get this? I think you can write S4 is equals to S1 plus X. Right?
Yes, ma'am.
Yes, ma'am.
Okay. Yeah. Gayatri, please you respond to me. You are getting it or not? Because I'm explaining it for you.
Okay, ma'am. Clear now. Clear, ma'am.
Clear? Okay. Okay. Let me erase it and we will solve it again. We will solve the question, not again, actually. Yeah, okay. Okay. Mhm. Mhm. Cool. So here we have S is equals to 3t square plus 4t plus 9. Right?
Yes, ma'am.
Okay. I need to find out the velocity at t equals to 2 seconds. For that, I need to calculate the instantaneous velocity. Okay? At t is equals to 2 seconds. So what we will do? V is equals to ds by dt. Just differentiate the entire expression. I'm not going to write it over and over again. I will do it, verbally. I differentiate this expression. It would become 6t plus 4. Then substitute t is equals to 2 seconds. And you will get 12 plus 4, which is 16 meter per second. Okay. Let's solve for the second part of this question, which is average velocity. In between 1 second to 4 seconds. For this, you need to calculate the total displacement, which is S4 minus S1 divided by 4 minus 1. For S4, you just need to put t is equals to 4 and solve the entire expression. It would become 4 square is 16, 16 threes are 48, right? I mean, just solve this question by yourself. Put the value t is equals to 4 in this entire expression to get S4. For S1, you need to put 1 in the entire expression and you will get S4 minus S1 and divided it by 3. You will have the answer. Okay, I'm going to leave this question on your end. Is that fine?
Yes, ma'am.
Okay.
Ma'am.
Now let's talk about the another variable of this motion in one dimension or kinematics, and that is acceleration. It is rate of change of velocity.
Velocity.
Yes. I told you that whenever you come across this rate of change kind of expression in physics, in 99% cases, you will have time in denominator. Okay. And here in numerator, you will get the whatever the physical quantity you have. So here it is change in velocity. So basically, some of the students get misunderstood by this fact that it is velocity by time. No, it is not velocity by time. For example, I gave you a chart over here that this is the value of t, this is the value of v, and at t is equals to 0 second, the velocity is 0. At 1 second, it is 2. At 2 second, it is 4. At 3 second, it is 6. At 4 second, it is 8. Okay, this kind of variation I have. So if I ask you about the acceleration from 0 to 1 second, you will write 1 minus 0. That would be the duration or the time, let's say t, in 1 second. What is the amount of change? 2.
2.
So it is 2 meter per second square. If I am interested in 0 to 2 second wala change, then you said, ma'am, duration, the time is 2, right? And the change is 0 to 4, which means 4. It is 2 meter per second square, right?
Yes, ma'am.
That's how we solve it. From 0 to this particular time, what will you do? The duration is 4 and it is the change is 8 minus 0. We always put change over here. Okay? In 1 second, by what amount the velocity changed? It either could increase or it could decrease. That is not the point of concern. But the thing is, there is a change in the velocity and I want to calculate the rate of that change. Is that fine?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
And the unit is meter per second square. Again, acceleration is of two types, average acceleration and instantaneous acceleration. You know what is average acceleration, what is instantaneous, because I told you about average and instantaneous concept, right? What you are supposed to understand from those things. So I'm not going to invest much more time in this discussion because I have done it, number of times. That acceleration is of two types, average one and instantaneous one. Average acceleration whenever you have a duration, and when I'm talking about an instant, it lies under this portion. Acceleration is dv by dt over here, and here change upon time taken. Is that okay?
Yes, ma'am.
Yes, ma'am.
You can also add one more point over here, and that is slope of VT graph. Slope of VT graph is acceleration. Cool?
Yes, ma'am.
Okay. Now, you should understand a few graphical points also, just to to get the idea what is given to you. For example, I gave you a graph like this. Let me make a straight one. Yeah, velocity and time. Let's say I draw a graph like this. Sorry, not like this. Yeah. Now, tell me, what is this? What you are getting from this graph?
Acceleration.
Okay.
The acceleration is same whole time.
Yes, Tamanna. So you can say acceleration is constant over here. Why? Because at any instant, if you are drawing this theta, it is going to be the same. And if theta is same, so you know ki m is equals to tan theta. If theta is same, tan theta is same, then slope is constant. Yes or no?
Yes, ma'am.
Yes,
Like
ma'am.
we have discussed this example over here. At every instant, you are getting only 2 meter per second square. It means it's a uniform acceleration. Acceleration is constant, right? Right.
Yes, ma'am.
Okay. Let's come here, velocity time. And you have a curve over here. Let's say this. Now, can you tell me, can you comment on acceleration basically? It is constant or variable or what?
Non-uniform acceleration.
No, it's variable acceleration. Since theta with the positive axis is changing with the time. So you will get a variable slope. Is that okay?
Yes, ma'am.
Yes,
Okay.
ma'am.
Acceleration increase होगा.
What beta?
Increase होगा वो.
Yep, it is increasing. Because slope is increasing, in the nature. There's one more concept which is associated with acceleration, and that is negative acceleration. Okay. Negative acceleration is known as retardation. Basically, let's assume a physical, condition. For example, you are on a cycle. Now, nobody is going to laugh on the cycle, right? You have to imagine that it's a cycle. It's a tire. It is the handle. And you are here. See, you are laughing. I said, there is no need to laugh. Have you seen that Welcome movie?
It's good, ma'am.
Yeah. In that Welcome movie, have you watched that particular scene where Majnu Bhai, draw that horse or something, that man, right? That kind of drawing.
Yes, ma'am.
Yeah. So it's a masterpiece. You need to, have a vision to understand these kind of drawings. It's a masterpiece. You're laughing. See, your bicycle, your bicycle is moving in this direction. Okay. But let's say somehow I came and I start pushing you in this direction. Okay. I keep pushing you. So at some point of the time, we're going to stop now,
Yes,
right?
ma'am.
Yes, ma'am.
This is the
Yes,
example of negative acceleration because I give you the acceleration in the opposite direction of motion. You are moving in positive x and I'm giving you the acceleration in negative x. So basically, I'm trying to stop you. And in that scenario, you will understand that whenever the acceleration, see, I'm writing it over here, whenever the acceleration is in opposite direction of motion, then we get the retardation. Okay. Since acceleration is a vector quantity, velocity is a vector quantity. So this is something that we can understand. Okay. This is the example of that situation. Fine. Let's do a question. Here you have a relation in between velocity and time. You need to find the acceleration at t is equals to 3 seconds and from 0 to 3 seconds. Again, you have two questions. Find it out. It's 1836 right now. Give me the answers about around 1838. And I think you remember that in the last class, I told you that we will extend our next class, which means this class. So we will do that, okay? Okay. So,
You told on Friday, no?
yeah, but there is a change in the timetable. Today, there's you have to take the class of biology, but that is shifted towards the I think Friday. Yes. Let me change. Let me check the timetable. I think it got shifted. Yeah, you will have your biology class on Friday, and today I'm taking your class, right? So we will extend this class. Is that okay, Harshita?
Yes, ma'am.
That's cool. So yes, you have 1 more minute to solve this question. Please do that. Okay, Janvi. Yes, Rihanna. This question or previous one? This one. Okay. So the question goes like this. You have a relation in between velocity and time. You need to find out the acceleration at t is equals to 3 seconds. That is your first part. In second part, you need to calculate the average acceleration from 0 to 3 seconds. Okay. So again, if you understand, then here you have two types of acceleration that you need to calculate. First is instantaneous and the other one is average acceleration. I told you to keep it in your mind always that whenever you have a duration, you will go with the average. Whenever you have an instant, you will go with the instantaneous physical quantities. Is that okay, Rehana? Okay, Joshua is giving me the answers. Okay, okay. So everyone, Janvi, Namrata, Tamanna, Harshita, please share your answers.
Ma'am, it's 8 meter per second.
Yes, ma'am. First one, 8 meter per second.
First answer
It is
is 8 meter
supposed to
per
be meter per second square.
4 meter per second.
I will reject your answers on the basis of units only.
8 meter per second square.
Yeah, that's cool.
Mhm.
Namrata, Mishpa,
Yes, ma'am.
Per second.
8 meter per second square.
that's cool. That's cool. Let's solve this question then. So here we have v is equals to this. We need to find out the acceleration. See, the question says that at t is equals to 3 seconds. It means we are talking about an instant. And if I'm talking about an instant, then I need to calculate the instantaneous acceleration. right? And A is equals to dv by dt, which is d by dt of 2t square minus 4t, and it would become 4t minus 4.
4.
At the place of t, just substitute 3 seconds. And it would become 4, 3 minus 4, which means 12 minus 4. And yes, it is 8 meter per second square. Now we need to solve the another question, another part, which is, let's see, yeah, let's do this. From 0 second to 3 second. Okay, we will solve it then. For average acceleration, you need to write out the velocity v3 minus v0 divided by 3 minus 0. When you put t is equals to 3 in the above expression, you will get 3 square is 9, right? 9 2s are 18. 18 minus 4 3s are 6. Sorry, 4 3s is 12. Minus 0 upon 3. It would become 6 by 3, which is 2 meter per second square. Is it okay?
Yes,
Yes,
ma'am.
ma'am.
Okay. Cool. Yes, Harshita, do you want to ask something or?
No,
what?
ma'am.
Okay. So this is your homework question. Kindly mark it as your homework question and take the screenshot. Okay. Done? Yes, Mantisha, do you want to ask something, beta?
Yes, ma'am. Can you please repeat?
Yes, why not? See, here we have to find out instantaneous acceleration corresponding to this instant t is equals to 3 seconds, and then average acceleration corresponding to this duration. Okay, you just need to stick this thing into your mind that whenever you have a duration, you will go with the average. Whenever you have an instant, you will go with the instantaneous, okay, physical quantity. For instantaneous, always do the differentiation. For average, go with the total, whatever the change upon total time taken. Is that cool? Okay, Mantisha. Chaliye, this is your homework question. Let's discuss equation of motions also. There would be a lot of ways to prove it. I'm going with the basic one, and I'm going to give you the hardest one as a responsible teacher. So basically, you have 3 equations of motion. Make sure one thing that you remember it. We have a prior condition where we apply these equations, and that condition is acceleration is supposed to be constant. If acceleration is not constant, you cannot use these equations. I mean, as a human, you can use and you will get the wrong answers. Okay. So the concept is, if acceleration is constant, then you will only use these equations. Number 1, which we known as the first equation of motion.
V is equals to U plus AT.
Very nice. V is equals to U plus AT. Here, V is the final velocity. U is the initial velocity. A is your acceleration. T is the time. Right? Then we have the second equation of motion, which is S is equals to UT plus
T plus 1 by 2 AT
AT
square.
square.
Very good. Remember one thing, this S is displacement, not the
Displacement.
distance. Okay. Let's go with the third.
V square is equals to U square
V
plus
is
2A.
equal to U plus A.
Very nice. So these are the equations of motion. There could be a lot of ways to solve it. You can do it analytically, you can do it graphically, you can do it by differentiation integration. I'm going to give you the derivation with the very simplest one, and that is graphical. You need to do it by differentiation, okay, and integration. I'm going to do the easiest one. So let's say I have a graph over here like this. This is V, this is T, okay? And this is the initial velocity. Why this is the initial velocity? Because T is equals to 0 at this point. So this is U. This entire distance is V, okay? What I did, I just draw this perpendicular over there. So this column would be V minus U. Is that okay?
Yes, ma'am.
Okay,
Yes, ma'am.
cool. So just calculate the slope of this graph. Slope is equals to tan theta and tan theta is equals to perpendicular by base. Here perpendicular is V minus U and base is T, right? Perpendicular is V minus U and base is T. Okay. This slope is equals to acceleration. As we know, the slope of VT graph is acceleration. So from here, just do the cross multiplication. You will get V minus U. And by rearranging the expression, you get first equation of motion. Is that okay?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, let's come to this one. Again, you have this graph. Okay, just give me a minute. Let me connect my charger. Okay. So this is velocity versus time. And again, you have the same graph like this. So basically, this is your U. It is V. It is T. And this much is V minus U. Is that okay? Yeah, Rehana, do you want to ask something, beta? Rehana. Okay. Okay, see, just calculate the slope out of it. Slope is tan theta. If you have this triangle A, B, and C, the perpendicular is AC now, and the base is CB. Just put the values. It is 0, it is T, this thing is T, and I just need AC, not the entire, length. So if this much portion is U and this entire length is V, then it would become V minus U, right? Let's come to this S is equals to UT plus half AT square. See, remember one thing, that the area under the curve of VT graph is displacement. Okay? Area under the curve is displacement, which means this one. This is displacement. So I guess you can see this entire graph is actually formed by two figures. One is rectangle and other one is triangle. So you can write it like this, that S is equals to area of rectangle plus area of triangle. Yes or no?
Yes, ma'am.
So the length of this rectangle is U and the breadth would be T. So it is UT plus the area of triangle is half into base into height. So let's say this is 90, this is theta. So if you are considering base V minus U, the height would become T. Okay? From first equation, you can have V minus U as 80. You can check it over here. V minus U is equals to 80 now. Just substitute this value over here. UT plus half AT multiplied by T, and this become your second equation of motion. Right?
Yes, ma'am.
Right. Now let's come to the third equation of motion and the last topic of today's class. So I didn't take much time. V versus T. This is displacement. Sorry, again, velocity versus time. This is the curve. I don't know why it is, coming out like this. Yeah, this is your curve. Where this is U, this entire thing is V, and this much portion is V minus U. एक second. I will go through your message, Miswa. Can you see this figure is also a trapezium, right? This is trapezium also now.
Yes, ma'am.
Yes, ma'am.
So you can write it like this. Ki S is equals to area of trapezium. Can you give me the formula for this one? What is the area of trapezium?
Half into length of parallel sides.
Half into sum of parallel sides into height. Right?
Yes,
Now,
ma'am.
parallel side is this u and this entire expression, this. These are the parallel sides. So what will you do? U plus v over here.
Minus.
And height is t. Right? Now, again, from first equation of motion, you can write t as v minus u by a. Okay? So just substitute it over here. You will get v plus u from here and v minus u by a from here. Right? So it would become 2as is equals to, see, it is the identity a plus b, a minus b, which will give us a square minus b square. Right? And you will get your third equation of motion. So this is my, my way to explain the three equations. It's your homework. See, I'm writing your homework over here and please take it very seriously. Number
Ma'am,
one,
will you share this PDF on the group?
okay. Drive the all basically you have the link in your Google Sheet now.
Yes, ma'am.
Drive the equation of motion by differentiation method. Okay. Second, do basic mathematics. I don't know how you're gonna do that. These are 6 lectures and it is in my bit.ly sheet. Please do it. At least do integration and differentiation for time being. Although you need vectors also, but okay, that's your choice. Please do it. Okay, it says please. And thank you so much for being so nice.
Thank
And-
you, ma'am.
Yeah, to give me a
Ma'am,
wonderful.
both the methods were to derive the equation.
Thank you, ma'am.
Thank you. Welcome, बेटा. क्या पूछ रहे हो?
Ma'am, by both the methods were to derive the equation.
Can you please come again?
And by differentiation method and integration method also we have to derive the equation.
That is something which you just do for your, concept clearance. Otherwise, that is not required because the kind of exam we are going to take is, MCQ based. Nobody is going to ask you derive the equations. I'm just asking you to solve it so that you get the basic idea of differentiation and integration. That's it. That's the point.
Okay, ma'am.
Okay. Take care. Bye bye.
Bye, ma'am.